All right, so we're going to talk about titrations. A titration is a technique used to determine the concentration of a solution. So you might have a solution and you don't know what the concentration is, so titration is a way to actually determine the concentration of a solution. And so remember, concentration is measured in molarity, and molarity is just moles per liter, right? Okay. So the type of titration we'll be working with in class is the most common one, which is called acid-base titration. And so what it has to do with its equivalent points. It's the point at which the concentration of hydrogen ions is equal to hydroxide ions. This is called an equivalence point. And what that means is, at this point, it's neutral, right? So the idea with this titration is if, for example, you had an unknown, but remember, concentration molarity is moles per liter, right? And so it's really easy for us to determine, like, the volume. Because we just take the solution and figure out the volume, right? But the hard part is the moles. It's not like we can look at that solution and be like, oh, there's 3 moles in there. We have to kind of figure it out. But we do know that if this were a acid, we would know that there's some amount of H plus ions, right? So there's some amount of H plus ions. It's unknown, okay? But what we could do, though, is if we added, say, a base, like sodium hydroxide, we could actually figure out the number of moles added in order to neutralize the solution. So, for example, let's just say if I added 3 moles of NaOH, or in this case hydroxide ions, right? And I found out that the pH was 7 after I added the 3 moles. I know there's 3 moles of H plus. And then if I know there's 3 moles of H plus, and I know that for every 1 mole of HCl, it breaks down to 1 mole of H plus Cl minus, right? So for every 1 mole of this, I have 1 mole of this. So now I figured out, oh, there's 3 moles of HCl in, let's just say this was 20 milliliters. So now it would be, convert to liters, would be 0.020 liters. So by adding, if we have an acidic solution, by adding a base, and since we know the concentration of the base, we know the number of moles that we're going to add, we can actually determine how many moles it takes to neutralize the solution. And once we neutralize the solution, we can figure out, okay, now that we know it's pH 7, I use 3 moles of OH minus, I can actually figure out how many moles of H plus and then how many moles of the acid there are. Okay? Let's just do an example. So if I take 11.2 milliliters of 0.500 molar HCl and neutralize 20.0 milliliters of NaOH, what is the molarity of NaOH? Let's just draw a quick picture. So in here, I have an unknown molarity of NaOH, right? So remember, NaOH breaks down into Na plus OH minus. One thing I want you to notice is there's a 1-to-1 ratio. So in this, what we call dissociation, there's a 1-to-1 ratio. So there's an unknown amount of OH minus floating. But what we can do is if we add HCl, we can figure out, if we figure out the moles of HCl that we added, then we can figure out the moles of OH minus there are. Okay, so it says we have 11.2 milliliters of 0.500 molar HCl. So that's what we added. If you remember, molarity equals moles per liter. So if I have 0.500 molar of HCl, I want to figure out the moles and have my liters here, my volume. And so that's going to be 0.0112, right, liters. So if I multiply the two, I'll get my moles, right? So if I multiply this by this, I'll get my moles. So the moles equal 0.500 times 0.0112. That equals 0.0056 moles of HCl. So I just figured out that I needed to add this many moles of HCl. Now, if you remember, when I put HCl in water, it dissociates or ionizes into H plus Cl minus. But I want you to see it's a 1-to-1 ratio. So if I have 0.0056 moles of HCl, I also am adding 0.0056 moles of H plus. Now, if I use this many moles of H plus and then the pH is 7 or it's neutral, that means I also know that there was 0.0056 moles of NaOH. Well, one way, the reason why I know it's NaOH is because, remember, that for every 1 mole of NaOH, there's 1 mole of OH minus. So really what I'm saying is, to neutralize, we know this is the equivalence point or neutral point, so this is OH minus, right? But that, since for every 1 mole of this, they're basically the same, right? So you have 0.0056 moles of NaOH. Right? So once you have that, it's actually pretty easy, because now I have the moles of NaOH. I want to figure out the molarity. So we'll use that equation one more time. Molarity equals, well, we know the moles, right? 5,6 moles of NaOH all over, and how many was this? So it's 0.0200 liters, right? You got to convert it to divide by 0.02. So the molarity of NaOH is equal to 0.28 molar NaOH. Okay. Yeah, let's try this one. So I would press pause, try this on your own. So for this one, we took this amount of HCl, so we have an unknown amount of NaOH. So there's an unknown amount of NaOH. And we're going to add HCl. We know how much HCl we're going to add, right? So it took this much to neutralize. So this amount of HCl neutralizes this amount. So we know that they're going to, at the equivalence point, remember H plus equals OH minus. All right, so let's first figure out the moles of HCl we use, and from that the moles of H plus. So always use that molarity equation. So molarity equals moles over liters, right? So we know the molarity is 5.00 molar. The moles, the liters is going to be 0.0520 liters. So cross multiply, I would get the moles equal 0.26 moles of HCl. So that's how much I added, right? And remember, if I have 0.26 moles of HCl, I have 0.26 moles of H plus. If I have 0.26 moles of H plus, that's what it took to neutralize, so that means that has to be 0.26 moles of OH minus, right? And that would mean that there would be 0.26 moles of NaOH. Why? Because NaOH, for every 1 mole of OH, is going to be equal to 1 mole of NaOH. Why? Because the dissociation, when NaOH breaks down in water, breaks down into Na plus OH minus. All right, so now I know I have 0.26 moles of NaOH. It's time to determine the molarity of NaOH. So the molarity equals 10. It's moles over liters, right? So 0.26 moles divided by 10 milliliters, which is 0.010 liters. So that will equal 26 molar. Well, that's really strong. Okay. All right, so you have more practice with the pre-lab to work on.